In this video, you'll be learning how to solve problems involving unequal sharing and grouping using knowledge of fractions and multiples. This learning objective has been separated into two activities. In part one, we're going to solve ratio problems involving fractions and percentages. And in part two, we're going to use our knowledge of multiples. Your first activity is a group of questions relating to fractions or percentages. We're going to work through how to solve this style of question. So we're going to start with an example which isn't on your worksheet. Michael had run 2 kilometres of a race. He had 60% of the race left. What distance of the race was left? And what was the total distance of the race? Okay, these questions can always seem quite complicated because there's a lot of information in them. We need to pick out the important bits. So let's start by highlighting. He had run 2 kilometres. So he'd already completed 2 kilometres. He had 60% of the race left. Okay, so let's pick that apart because this is where some people can get confused and make some errors. He'd already run 2 kilometres and he had 60% of the race left. So if we imagine, I'm just going to draw this visually. Imagine this is his starting point and this is his end point. That's where he started. This is where he'll finish. He has 60% of the race left. He has 60% of the race left, so I'm going to just put in, this is not to scale, he's still got 60% left, okay? He'd run 2 kilometres of the race, so he'd run, so far he's at this point, where he's run 2 kilometres, but he's still got 60% left. What distance of the race was left? We need to think about what this is as a kilometre. What clues do we have? We can start to think about what we don't know now. So if that's 60%, we don't know what percentage this is. But if the whole race is 100% and he's got 60% left, we can assume, well, he's already run 40% of the race. So he's already run 40%. And he's got to 2 kilometres and he's got 60% left. This can help us. Let's write what we know. 40% equals 2 kilometres. We know this because he's got 60% left and he'd already run 2 kilometres. So we know that 40% of the race is 2 kilometres. How can we use this to figure out what 60% is? Now we could think about scale factors. You may have watched some of the ratio videos and scale factors. What do we multiply 40 by to get to 60? And then we can apply it here. But if 40 doesn't fit into 60, if 40 isn't a factor of 60, how are we going to figure this out? Well, you may be able to spot how many times 40 goes into 60. If not, how about going down to how about finding a common factor? So I'm going to make 40 go down, I'm going to find 20%. I'm going to halve my 40. Half of 40 is 20, half of 2 is 1. If I know that 40% is 2 kilometres, I know that 20% is 1 kilometre. So if I do that, does that now make it a bit easier to find out what 60% is? Because I think it's easier to see what I have to multiply 20 by to get to 60 than it was to find out what I had to multiply 40 by to get to 60. And it doesn't matter, I could go up or I could go down. As long as I keep doing the same this side to this side, I will get to the same answer. So 20 needs to multiply by 3 to get to 60. So I need to multiply this by 3, which is going to tell me that 60% is 3 kilometres. Can you see how going down to 20 helped me to go up to 60? Now, if you did spot the link between 40 and 60, which you may have done, it was to times it by 1.5. 40 multiplied by 1.5 makes 60. If I multiply 2 by 1.5, it gets to 3. So it gets to the same answer. It will not alter your answer. The route that you go to find your answer doesn't matter. It's about making sure you're accurate. Let's take a look now at the question that is on your worksheet. If you want to solve it independently, then pause, and when you've done it, watch the video back to see if we're on the same track. Or if you're really confident, you can skip this part of the video. Otherwise, if you're staying with me, I am going to talk through how to solve it. So just pause at any time that you feel you might want to give it a go. Okay, Jason swam 350 metres across a lake. He has 3/5 of the lake left to swim. How many metres are left to swim? This is very similar to the question we just worked through together. So if I think about Jason starting, and Jason finishing, he swam 350 metres. He has 3/5 left, so I'm going to do, that's my 3/5, and he's got here, which is 350 metres. So what can I say about this fraction here? If he's got 3/5 left, what fraction has he already swam? If you've seen it and you think you can pause and go ahead independently, then do so. So he had already swum 2/5. So from using this information about what he had left to swim, I can figure out that 2/5 was 350 metres. 2/5 of the lake was 350 metres. Now, if I know what 2/5 are, I can use this information to find what 1/5 is. Because 1/5 is half of 2/5. 1/5 plus 1/5 makes 2/5. So to find what 1/5 is, if I divide that by 2, I divide that by 2. And half of 350 is 175. So if I know what 1/5 is now, and I know what 2/5 are, it's going to help me to figure out this question. How many metres are left to swim? Well, he's got 3/5 left. How will I find 3/5? Using the information on the screen. I could multiply this by 3, or I could add both of these up. I'm going to leave you to do that. And B, what is the total distance he will swim? What would be the complete journey? What would be the complete race? The fraction would be 5/5. When he's finished and he's completed the race, he will have done 5/5 of the race. So if I know what 1/5 is, can I use that to find out what 5/5 is? If you figured out your 3/5, could you add it to your 2/5? It will all come to the same answer. So using this information, you're able to find out, using this information, you can find out what 3/5 is. And then using all of this information, or any of this information, you should be able to find the total distance, which will be this. Okay, let me give you some hints for the next one. Melina read 20% of a book on Monday, twice that amount on Tuesday, and she has 200 pages left to read on Wednesday. How many pages did she read on Tuesday? How many pages were in the book? Okay, always best to break these things down step by step. So on Monday, Melina read 20%. On Tuesday, she read twice that amount. So what is twice? What is twice of 20%? Well, it's 40%. So I could add these. On Wednesday, she's left with 200 pages to read. Okay, so she's got 200 pages left to read. What percentage does she have left to read? If she's read 20% and 40%, what percentage is there left? Well, between these 2 days, she's read 60%. So what percentage does she have on Wednesday? And whatever that Wednesday percentage is, equals 200. So when you figured out the percentage that she has left on Wednesday, you can write that percentage equals 200. Once you've figured that out, you can work backwards to figure out, to compare this percentage to the 40% on Tuesday, and also to figure out how many pages were in the book altogether, which would be 100%. Now pause and give it a go. If you're really not sure, I'm going to talk through this bit now with you. So if she'd read 60%, then we know on Wednesday she has 40% left. So we know that 40% equals 200. If I know that 40% equals 200, then I know that Tuesday, which was also 40%, is 200. And if I know that 40% is 200, then I'm going to know that 20% is 100. So if I added up Monday, Tuesday and Wednesday, I have my answer for how many pages were in the book, which is 500. Let's look at the next one. Jasmine walked 1/3 of a journey before lunch. After lunch, she completed the remaining 9 kilometres. How far did she walk before lunch, and how long was the complete journey? Okay, I'm going to write a number line again just to illustrate. So if this is Jasmine's journey, she walked 1/3 before lunch, and after lunch she completed the remaining 9 kilometres. The remaining 9 kilometres. So from here to here was 9 kilometres. What fraction was it from here to here? If she'd walked 1/3 and she completed the remaining, that would mean that this was 2/3. So I now know that 2/3 equals 9 kilometres. How will I use this information to figure out what 1/3 is? If I know what 2/3 is, what will 1/3 be? Think about my scale factors. Well, 2/3 divided by 2 makes 1/3. 2 lots of 1/3. 1/3 plus 1/3 makes 2/3. So I'd need to divide that by 2 to figure out what 1/3 is, and that will tell me my answer to question A. Once I've got my answer here and I put it here, I can add these two amounts to figure out how long the complete journey was. So try and give that a go now. Otherwise, if you stay tuned, I'm going to go through the answer. So 9 kilometres divided by 2 is 4.5 kilometres. If 2/3 is 9 kilometres, then 1/3 is 4.5. 1/3 is half of 2/3. So I could write down that the first part was 4.5 kilometres and the second part of her journey was 9 kilometres, and now you would simply add them. 9 plus 4.5. Fill in missing decimals. 5 decimal point 9 plus 4 is 13, and that gives you your answer for her complete journey. In our final activity, we are going to be working through some statements using ratio. It's very important to look at the question in bold because each time it might be asking you for different parts of your working out. So let's work through some of these together. Here is an example in the same style as the questions on your worksheet, but this one is not on your worksheet. For every jogger in the park, there were 3 dog walkers. For every dog walker, there were 2 children. There were 16 joggers in the park. How many children were there? Okay, there's a lot of information there. So try not to be intimidated when there's lots of information. Let's work through it step by step. For every jogger, there were 3 dog walkers. So I'm going to put J for jogger and DW for dog walker. For every jogger, so 1 jogger, there were 3 dog walkers. 3 dog walkers. For every dog walker, there were 2 children. So if there's 3 dog walkers, there must be 6 children. Okay? So for every jogger, there were 3 dog walkers. And for every dog walker, there were 2 children. So there's from here to here is doubled, and from here to here was tripled. So I have to double this section. So there was 1 jogger. If there was 1 jogger, there would be 3 dog walkers and there would be 6 children. Okay, and then I like to add up all my parts. So in total, 1 plus 3 and 6 is 10. Okay, now let's work through the rest of the information. There were 16 joggers in the park. Okay, so I can put that under here. How many children were there? Okay, well, we can work through this. We can compare this to find our scale factor. What do we multiply 1 by to get to 16? We multiply by 16. So we apply it to all the other parts. 3 times 16 is 48. And 6 times 16 is 96. I appreciate that you may take longer to multiply these, but I'm just showing you the skill. Okay, so if you were working through this problem, there's nothing wrong with writing down what 16 times 6 is. But that is how we work that out. How many children were there? I can now go to my children section. If there were 16 joggers, there would be 96 children. If there were 16 joggers, there would be 96 children. Okay, now I'm going to rub out that bottom line. So I go back to my original clues. There were 36 dog walkers and children all together. How many joggers were there? Okay, well, if I just ignore the joggers for a moment and go back to my initial, for every dog walker, there were 2 children. So if I do another one here, dog walker to children, for every dog walker, there was 2 children. That adds to 3. There were 36 dog walkers and children altogether. 36. I can use this to find my scale factor. How many times does 3 fit into 36? Well, it fits in 12. So if I multiply dog walkers by 12, I have 12. And if I multiply children by 12, I have 24. So now I have the information to put here. If I have 24 children and I have 12 dog walkers, how can I find out how many joggers there were? Well, I've actually got 2 columns of information I can use now. I could either find the scale factor from this column or the scale factor from this column, because they should both be the same. So how many times does 3 fit into 12 and how many times does 6 fit into 24? Well, it fits in 4 times. These 2 fit 4 times into these 2. So my scale factor is to multiply by 4, which I can now apply to my joggers. 1 times 4 is 4. So there were 4 joggers. So this example is one from your worksheet. So don't watch this video if you want to have a go independently. Otherwise, stay with me and I'm going to talk through how we would approach this. Mariam sent out some invitations Mariam sent some invitations out to a fundraising coffee morning. For every 5 invites she sent, 3 people said they could come. Altogether, 42 people attended. How many invites did she send? Okay, now we need to be careful that we label each part of this correctly. So for every 5 invites she sent, 3 people said they could come. So we need to think about, if she sent 5 out and 3 people could come, how many people then couldn't come? So if I put a tick, 3 people could come, which would mean 2 people couldn't come. And this is how many invites she sent. So for 5 invites, 3 people could come. I've just filled in this information which isn't in my statement, but I can deduce this from my statement. If 3 people out of every 5 said they could come, that would mean 2 couldn't come. Okay, altogether 42 people attended. How many invites did she send? So 42 attended, that means that goes in that column. 42 people attended, 42 people did come. How many invites did she send? So I want to know this. So I'm going to use this to find out my scale factor. How many times does 3 fit into 42? So if you haven't had a go yet, pause now and have a go. Find your scale factor. What am I multiplying by to get from 3 to 42? Then can you apply it to the other parts? And this is the one that I need to answer my question. So hopefully you're now coming back after giving it a go yourself. If you weren't sure about 42 divided by 3, use the bus stop. 3 into 4 goes once with 1 remainder. 3 into 12 goes 4 times. So my scale factor was 14. So 2 times 14 is 28. So 28 couldn't come. Now I could either add these 2 together, 42 and 28, or I could do 5 times 14. Both get me to 70. She sent 70 invites out if 42 people came. Okay, I'll go through a couple more examples, so pause when you're ready to give it a go yourself. A bag of sugar weighs 5 times more than a box of tea bags. Together they weigh 1.8 kilograms. How much does the sugar weigh? A bag of sugar weighs 5 times more than a box of tea bag. So sugar to tea. 5 times more means 5 to 1. That's 5 times more than that. Remember, I like to write the total here. I'm going to put W for weight. Together they weigh 1.8 kilograms. How much does the sugar weigh? So I need to find my scale factor here, 6 to 1.8. Now you might recognise this scale factor here. If you do, then give it a go. Or you might even do 1.8 divided by 6. Divided by 6, and then you could find your answer. Or another way is actually you could change your 1.8 kilograms to grams. What about if you made it 1,800 grams? Would it be easier now to figure out a scale factor. Now remember, if you do this way, you're going to get your answer in kilograms. If you do it this way, you're going to get your answer in grams. So have a think about which way you want to do it. Give it a go independently now if you haven't already. Okay, I'm going to go through now what we could do. So to get from 6 to 1800 is to multiply by 300 grams. And to get from 6 to 1.8 is to times by 0.3. So if I was going to figure out in grams, I'd need to multiply all of this by 300. So tea bags would be 300 grams, and my sugar, 5 times 300, would be 1500 grams. If I was going to use this method, timesing by 0.3, 1 times 0.3 would be 0.3 kilograms, and 5 times 0.3, well, I know 5 times 3 is 15, so 5 times 0.3 would be 1.5 kilograms. And if you compare, 1.5 kilograms is the same as 1,500 grams, and 0.3 kilograms is the same as 300 grams. But that gives you two different ways of solving that problem. The final example that I'm going to do with you, Isabel hid some Easter eggs. For every 4 she hid, 3 were found. Altogether, 21 were found. How many did she hide? Okay. Hid, found. For every 4 she hid, 3 were found. Altogether, 21 were found. How many did she hide? This is a simple ratio problem. You have got the information we've plotted down, you've got the clue here, you simply need to find the scale factor here. Okay, once you've got the scale factor here, you can apply it here. The other way you might have done is you might have put found, not found, hidden. So for every 4 she hid, 3 were found, which means 1 wasn't found. Okay, so you could do it this way as well. Altogether, 21 were found. How many did she hide? Doesn't really matter if you do it this way or this way. It's going to be the same thing. Here is your information to compare. You're just finding your scale factor. What's your scale factor there? You can then apply it to there, and you could find this, but this is the answer we're looking for. So if you haven't already, this is your last chance to give this a go on your own, because I'm about to go through the answer now. So to get from 3 to 21 is a scale factor of 7, which means I need to multiply my 4 by 7, which is 28. If I did it this way, to get from 3 to 21 is still 7. All it means is that I could have identified how many weren't found as well as how many were hidden altogether. But the question is, how many did she hide? So you would need to make sure that you extract this answer, the 28. Okay, give those questions on your worksheet a go now. Remember to write down the ratio as I have done here, and always try and put your total as well. Okay, good luck. Well done, you've finished your video and the activities where we've been looking at solving problems involving unequal sharing and grouping, and we've been using our knowledge of fractions and multiples. When you feel ready and confident, have a go at the past SATs questions. There are always questions about ratio in SATs papers, so have a look and see the different ways that they've been presented.